Continuing where I left off, so it's talking about that second reaction. That's the reaction where the copper 1 carbonate hydroxide hydrate decomposes into the copper 2 oxide, the black powdery substance. These two molecules of water are lost, they come out, as well as one molecule of carbon dioxide. So the mass that's left behind, the copper 2 oxide, is 3.327 grams. The mass of the initial hydrate was 5 grams. So the empty crucible was 88 grams. To it you added 5 grams of the hydrate, so it's 93 grams hydrate plus crucible. The mass after the heating, what was lost is the water and the carbon dioxide. So 2 molecules of water as well as that 1 molecule of carbon dioxide, right? So that's 93 minus the mass that you obtained after the heating process, which is 91.327, right? So 93 minus the 91.327 gives you 1.673, right? So this is the combined mass of the waters and the carbon dioxide that was lost. The crucible and the copper 2 oxide, that was the mass after the heating, was 91.327, all right? So if you subtract this from the 93, you get the mass of the water that was lost, all right? Now, if you take the crucible and the copper 2 oxide and you subtract out the empty crucible mass, you get the mass of the copper 2 oxide, which is 3.327. You take the grams of this copper 2 oxide divided by the molar mass of the copper 2 oxide, which is 79.545 grams per mole, and you get the moles of copper 2 oxide, which is 0.042 moles. So the mass lost, that is this 2 moles of water, 1 mole of carbon dioxide, it's 1.673 grams. Okay. If you take 2 moles of water, that's 36 grams, because 1 mole of water is 18, so 2 would be 36. 1 mole of carbon dioxide is 44 grams, so the total mass is 80 grams. Okay. If you take the mass of water divided by the total times 100, that's 45%. So 45% of 1.673 grams would be 0.75 grams of water. Okay, so the grams of water that left the hydrate would be 0.75 grams of water. In the third experiment, zinc is taking the place of hydrogen, so it's displacing hydrogen, and hydrogen comes out, bubbles out, and you were able to trap it and then take it into a syringe and note down the pressure and the volume of that hydrogen gas. Okay, so this is the balanced reaction. 1 mole of zinc, 2 moles of HCl, giving you 1 mole of zinc chloride and 1 mole of H2. The fourth experiment is the double displacement. So the balanced reaction is 2 moles of sodium hydroxide combining with 1 mole of nickel 2 chloride. Okay, exchange of dance partners, and you get the sodium and the chloride forming sodium chloride staying in the water, and then the nickel and the hydroxide forming nickel 2 hydroxide. Okay, And that's the solid, the precipitate. So whichever is aqueous is basically staying in solution, right? So this is the balanced equation, and then when you break it down, NaOH dissolved in water separates out into the sodium ions and the hydroxide ions. NiCl2 again separates out into the nickel 2 ions and the 2 chloride ions. But when nickel and hydroxide come into contact, then they come out of solution and form nickel 2 hydroxide, which is a solid. So that's the net ionic equation. Nickel ions combining with the 2 hydroxide ion forming NiOH2, the precipitate. So what was the aim of the first experiment? The aim of the first experiment was to determine what would happen to the magnesium metal when burnt in air. It also confirms that burning of the magnesium metal is a synthesis reaction because magnesium and oxygen combine to form magnesium oxide. Aim of experiment 2 is what would happen when copper 1 carbonate hydroxide hydrate is heated, and also to confirm that this is a decomposition reaction because when heated the mass comes down, all right, mass is lost. Experiment 3 is to determine what will happen when zinc and hydrochloric acid react. You will see the bubbling of the hydrogen showing this is a single replacement reaction and the disappearance of the zinc. Experiment 4 is to observe what will happen when sodium hydroxide and nickel 2 chloride solutions are mixed. It's also to confirm its double replacement because you see the formation of nickel hydroxide as a precipitate. So my first hypothesis for experiment 1 is that the final mass of the crucible will go up because the magnesium will get oxidized. For the second, after heating, the contents is going to weigh less than before because some of that hydrate is going to decompose in the form of the water molecules. For the third experiment, my prediction is that zinc will react and will be able to replace hydrogen in the acid. This is a typical metal acid reaction because metals dissolve in acid and usually hydrogen gas is evolved. Hypothesis for experiment 4 is that nickel 2 hydroxide will come out of solution, and the reason I know this is because of the solubility rules, and most hydroxides are insoluble in water, and that would be nickel 2 hydroxide would be insoluble in water according to the solubility rules. So list all your equipment for each experiment. And then write down the detailed procedures as I referred to it in my previous slides, and then write down your observation, that is your data. Okay, so the mass of the crucible and product is going to be larger than the mass of the crucible and reactant as predicted in experiment 1. So here I'm talking about the results, not just the data, right? So the shiny metal disappeared and its place was that fine white powder of the magnesium oxide. Experiment 2, mass of crucible and product was less than mass of crucible and reactant, and the green color of that reactant, the hydrate, disappeared and the product was black in color. Experiment 3, the zinc reacted with the hydrochloric acid because it started disappearing, and then I saw bubbles of the gas, the hydrogen gas, appearing. And then experiment 4, the sodium hydroxide was colorless, the nickel 2 chloride solution had a green color, and then mixed light greenish yellow precipitate started forming when the two solutions were mixed up. So the results are as follows. We went over this in the previous slide. The mass of oxygen in the product was 3.289 grams. Okay, so basically you had 5 grams of the magnesium, and then when you add the mass of oxygen, all right, mass of the magnesium oxide is 8.289. okay, so that final mass was 96.289. If you subtract the mass of the crucible, that's the mass of the product, 8.289, and if you subtract 5 grams mass of the magnesium, you get 3.289, which is the mass of oxygen. So you take the mass of oxygen, 3.289, divide it by the mass of the magnesium oxide times 100, right? And you get 39.7%. So that's the percentage mass of oxygen. And again, because we know from literature, when you do the percentage mass of oxygen in a typical magnesium oxide compound, it would be 39.7%. So the mass that was lost this was the mass of the hydrate, and then this was, after the heating process, this was the mass of the anhydrate, which was the copper 2 oxide. When you subtract one from the other, you get the mass that was lost, which was 1.673 grams, and that includes those 2 moles of water and 1 mole of carbon dioxide. So this 2 moles of water is 36 grams because each mole of water is 18 grams. Okay, so 1 mole of carbon dioxide is 44 grams, a total of 80. So 36 divided by 80 times 100 is 45%. 45% of 1.673 grams is 0.75 grams of water. So zinc is displacing hydrogen, as we saw in the third experiment, and you get hydrogen gas forming. So initially sodium hydroxide was colorless, nickel 2 chloride was light green, and then a green precipitate or a solid of nickel 2 hydroxide forms. So what did I learn from all of these experiments? Some real world examples of each type of reaction. So experiment 1 showed that burning involves reaction with oxygen, right? So when you burn something, that means you are oxidizing it because oxygen from the air is reacting with that reactant. So the end product is an oxide. So most metals, when you burn them in air or oxygen, form oxides. These are mostly synthesis reactions. So the metal plus oxygen giving you a metal oxide. In the real world, rusting of iron is a synthesis because you have iron which over time combines with oxygen from the air to form rust, which is iron 3 oxide. And then in experiment 2, most hydrates, what will happen is they tend to lose water when they heat, they decompose. So you have a single reactant like the copper 1 carbonate hydroxide hydrate, and it breaks up to form several products, 3 products in all. The copper 2 oxide, the 2 molecules of water, and 1 molecule of carbon dioxide. And I will have to stop here and continue this in the next video.